managing architect at London Architecture Company, which is a Helsinki-based company of architecture. And first of all, to thank the organizers for the event, for the invitation, and to all the speakers for the wonderful presentations. So I titled my presentation "A New Era for Wood and Architecture." I think it has been the theme the whole afternoon. So I'm going to try to make a point on what is really the future. So as I said, we are based in Helsinki. It's actually a very beautiful building from the 60s. It's totally rounded in Virta. Finnish people knows. If not, you can go check it around. It's very nice. So we are based in Helsinki, but actually we have also projects in other locations in Finland and abroad. So we basically build in the innovation of the built environment, architecture and urbanism. So it's quite wide of a text, but what it means is that we try to tackle all the issues of architecture from urbanism until actual finalization. So office itself was founded in 2008 by Eero Lunden, the founder, and office unique approach is shaped by experiences over 400 projects in Finland, Estonia, China, Italy. Some things started in Uruguay and even in still have some projects. We normally collaborate, of course, with engineers, with other parties, but also with leading experts and also with other architecture offices, because it's a very fruitful collaboration when we discuss, knowing that we are working in the same boat. And so public, private, academic, and third sector organizations. So as a short sentence, the International Diverse team shares one vision, which is to produce innovative and sustainable solutions. So today I'm going to talk mainly on wood and construction, but I think the sustainable concept is actually a wider term, and I think it has to be tackled from many angles. Picture of most of our colleagues. And some of the projects that I will show, and also some of the areas that we cover in our company. So we work in architecture, wooden construction, we have also a landscape architecture team. We work in strategic land use, developing of big areas or like strategic developments. We have also urban planning, research, experimental projects, and even parametric design, so computational design. So things of the day, well, why wood, why sustainability, why research, I think it's been covered quite well. So I'll try to make a point out of it. I think has been already mentioned by some of you that actually the current mega trends are really supporting this movement of wooden construction and sustainable construction. We know that there is mega trends of demographics and social change. There's a very rapid urbanization, which has also been mentioned. There's a climate change, there is resource scarcity, there is the emerging global wealth, meaning that different areas are developing at a very high speed, which connects with the rest of the issues. And especially in architecture, there's a current discussion that I wanted to bring to you. So we are, in the last years, in the last months, has been a very strong talk on resilient cities, on digitalization, on artificial intelligence. We have also talked about energy efficiency, mass timber, which is the main thing of the day, but also disassembly and reuse of the buildings. So it's not just the materiality, but also like what do we do with the big picture of the cities, and also what happens after the building is done. So I took a screenshot of Design, which is Archdaily, and Design are the major media sources online for architects and designers in general. So I picked, they made this timber erosion series during this early spring, March, April. So I wanted to highlight a few of the texts or notes from leading experts all over the world. And I collected a couple of pages, maybe you can check in the presentation in detail, but I wanted to share a few of them that are, for us, for our company, very meaningful. So first one is that we need to start using our wood more efficiently. Has been highlighted also today quite a lot, even in the chain of production. But using wood doesn't automatically make a building sustainable. That we should always come back to the embodied carbon, which is something that also was brought up many times. And that's a bit more risky, but that we are actually right at the beginning, because it's been like relatively short, especially with the high rise. We're running like who makes it tallest or who makes the widest, and so forth. So it's really like it's been in the latest like 30 years, 20 years has been going on. So that's also a personal approach, but we think that sustainability and good architecture is a process. So that I'm going to show today some case studies. So we show our know-how and some pilots. Then I will show also some research projects. So we try with that to create new concepts and new tools that can support our work, our daily work. And finally, I try to show what are we kind of proposing for this kind of future of wood and architecture. So what are we working in the next years, which we want to move forward with new ideas and new steps for it. So in the urban planning level, we try to envision sustainable cities. I'm going to show a few examples of our work. This is a Tampere Travel and Service Center, which was done through a competition. We got the first prize together with Danish company Kobe back in 2014. It was a full master plan for the whole center of Tampere, which is the, if I'm not wrong, second biggest city in Finland. And I actually read this morning that it's the biggest inland city in the whole Nordics. So it's actually quite important note, and you can see that it's relatively close to Turku and Helsinki, so it creates this kind of triangle, which is very well used also for business. So the whole proposal was pretty back in time, but we tried to merge the idea of a structure of the city and the nature of the area, of the country in general. You know, that has very beautiful nature. So we tried to do this concept in the middle of the city, and we covered actually the train line is just in the middle of the city, so it was dividing the west and the east. Proposed quite bold solution, which is to cover the tracks in the middle part so that the two sides can be connected. We created a platform, we solved the level differences, and we introduced nature as a main kind of idea of the area. So we have been working on this in the master plan level for already almost 10 years and still going forward. It's a really big, challenging project because you need to tackle the project from many angles, not only architects or urbanists or cities, also the train company, BR in this case, and other parties that are really involved in this type of development. So it's been super nice and challenging. So here are some updated images a couple of years ago, 3 years ago maybe, of the proposed solutions in the master plan. So you can see here the old station, which is the brick building, and these kind of covered tracks. The tracks are just under this deck, and then the city on the other side, which is in a lower level and has straight access to the trains. And you can see here the sustainability approach of proposing wooden buildings. Actually, that's something very important we put already in the master plan. So we try to introduce the concept of wooden architecture from the master plan phase, because if we cannot forget that, then it's very hard to get back to it. So even in our imaginary, we are all the time working with these solutions. So here are some images from the upper level of the station, and then another urban project I wanted to highlight is this Finnish WoodworkingIndustries, which is with a full vision for new residential and commercial area in Finnish, which is very close by Kuopio. We have also a map here. So it's in the area of the Thousand Lakes, very well known for the rallies and things like that, but also because of the beautiful nature. And actually, Kuopio is a really nice city also. You have the chance to visit. So the location is pretty nearby Kuopio, and we proposed for the client full vision using wooden architecture in the different scales. And the main core thing was the sustainability of the whole area. So we're using, it's so-called like an eco village, so it includes all the technologies and the transportation nodes, and everything is related to the sustainability level. So those are some summer houses in the seafront of the area, and we propose also wooden high-rise buildings, or not high-rise, but like some floors for offices and for commercial. And even we propose something that will come back a bit later, a sports hall center made of this parametric design, which allows to make big frames or big spans without columns or any other structure. We've been working also with this type of parametrization. So those are the three angles in the master planning. Then maybe the one that interests you the most is actually built and kind of visible already. So I'm going to show you the multi-story housing project that we have done in the recent years in Finland. So it's, as I mentioned, between Turku and Helsinki, and it's a very beautiful place also. You can see here the nice nature. You can see the two buildings right in the right corner. And the wooden facade was really natural. This was actually pictures from when it was finished, and I revisited the field, I think a year ago. And now it looks slightly different. We know that wood reacts and the color changes, but actually it is pretty interesting how the whole facade has created this kind of gray patina, which in my opinion looks like great, and the citizens or the inhabitants have been very happy with it. And also power of the material, that you know that it changes, so you can use it in your benefit also, and try to create very good solutions in the years coming. Another project and another type of solution, CLT housing in Turku, actually is social housing for WT, which is the Turku social housing company, public company. we proposed, actually it was a pretty interesting project because it was two buildings, one fully in concrete and the other fully in wood. And the idea was that they can compare and get some data out of it so they can understand a bit better the processes and not only the process but also how has it been in the construction side and how are the costs and the CO2 footprint and all these things. Of course, for CO2 footprint is pretty obvious, but in the other themes they were interested to know like how much actually it affects to make the different buildings. So they're exactly the same building, exactly the same facades, but just fully different materials. So wood CLT system and wood facade and concrete structure and facade elements are made of concrete. And here you can see pictures from the corner. You can see even that even the wooden one has a bit more cleaners on it because you're allowed to have bigger panels, so you don't have this kind of seam that comes quite often with the concrete construction. And some section in the building we had also this community idea of having the staircases that have been placed through the building. And some details of the facade we also play with the size of the panels to create a bit of diversity in the quite monolithic blocks. And some images from the interior. This is the CLT building where you can see a certain amount of CLT exposed inside. And here you can see a picture of the CLT walls which were left untreated. And you can see the concrete building just on the opposite side. I would say that I would rather prefer to live in the wooden one, but you can choose yourself. And the last project that I'm going to show from this part of the presentation is this row houses in a less dense area in Helsinki. There's 3,200 square meters of wooden construction here in Helsinki, and you can see here it's quite a new area, and we had the chance to develop this 1, 2, 3, 4, so like 7 blocks or 7 buildings, row houses, and we worked a lot with sustainability ideas. You can see here that all the roofs are covered with green, that many apartments have their own yard, that there is a very strong connection between the interior and the exterior, which is a very Finnish thing, not to take advantage of nature and to go there and spend time. So even in a relatively dense area, we propose to have these very natural spaces. Then another part or like theme where we work a lot also and we include wood is in school designs. I think probably Mikko is going to present way more projects, but we have done our part also, and we have been developing through competitions, through clients, different projects in wood. And it's a very long project actually. We started back in 2015, so taking part on open competitions, and I'm going to highlight a few that to understand that it's a process. That is not that nowadays we are building this, but it has a very long story behind. So we got actually a purchase prize in the Jätkäsaari school competition, which is in Helsinki downtown, and we were proposing already the wooden construction back in 2015. Maybe it was not that hot theme there yet, but we really wanted and we really believed that it was the future. So we didn't win, maybe too risky, maybe too expensive, many reasons. But then we continued with it. And we also, in parallel with the construction, I'm not going to go into detail, but we have been also working on with the learning environments, meaning that we try to also foresee the future of a learning environment. It's a very strong topic in Finland, and we believe that there is a lot to say and a lot to do from our point of view. So this is another competition we also got a purchase, and this was a hybrid system where you can see the concrete columns and then beautiful roof that was going through the whole school with, in this case, having LVL or so to solve the technical matters. Neither we win, but proposed a pretty strong and bold solution, and we kind of added more knowledge to our office, and we kept on kind of testing with projects. It was the first opportunity to manage to create a learning environment made of wood, very small, 600 square meters daycare in Pärnu, which is in Turku again. And we tested details, we tested very small things. It was quite a small budget, but we really wanted to kind of connect with the knowledge that we have accumulated from the previous competitions and projects. So we still had this kind of idea of open learning spaces, so not much walls, a lot of wood exposed. And in recent years, 2020, we built this southern school and daycare in Lahti, which is in the north of Finland, pretty close by Oulu. In this case, we proposed in the competition, it was this kind of invited competition, we proposed the wooden construction and we won it, but because of many reasons at the end, the structure did shift to concrete. So it's basically a post and beam concrete. But we energetically thought that we're gonna just, take out the idea of the wooden idea. So we stayed with the same concept with the big canopies, which were intended to protect the wood for the facades and also to have some hint of wood in the interior. So I think we did a pretty good job on preserving the identity and showing that actually wood also for interiors and for other surfaces are very feasible. And also for us it was a learning, because then we need to do the details of the roofs and the facades and so forth. So it was a very good learning. So I'm going to show you some nice pictures of it. This big canopy covering the wood and in that sense protecting it from the weather. Interior image from the interior of the classroom, where you can see again the connection with the nature, and interior pictures from the main staircases where we proposed LVL staircase. Even though the whole structure is concrete, we still wanted to introduce that, because for us, we think that wood is also a very healthy material. It creates this kind of nice boundary with students, and I think it is also the future in public buildings in general. So another branch that I was mentioning after I showed the case studies is the research and new tools. We really have a full team even in the office working on digitization and smart architecture. So we create tools to try to understand better the processes and to help also to speed up our own processes. And here I introduce also this parametric approach to architecture, which is based on digitalization and computer tools. So we had a chance in 2011, many years ago, to make a small pavilion in Turku. And here you can see a bit of the data mining thingy and also construction site. So pretty much like a hands-on type of project, but again, an idea of understanding how it works so that we can increase our knowledge and then go beyond the most obvious. We also had the opportunity to curate the Elorunden was creating the Nordic pavilion in the Biennale in 2018, where we proposed, there's no wood in here, but a nice tree. The architects might know the building, it's Sverrefen pavilion, but the idea of the whole exhibition was really rooted on sustainability. So we created these breathing elements that were in the pavilion, so that people would reflect the connection between nature and construction environment, so that we create these breathing animals where temperature will change, or the daylight will change, or the dioxide level will change. Those big plastic balls will change also with it. We try to make it experience that actually we live in buildings that move, that breathe, that they kind of interact with us in the same way as nature does. And here again, digitalization and technology and trying beyond the normal. Here a picture of the interior of this light system. When it was colder in the building, it was getting warmer color, and when it was getting warmer outside, the color was colder. So just artistic approach of explaining what I'm putting in this presentation. Another chance of developing more this parametric design shapes was in the Burning Man Festival in Nevada in 2017. So we tried a slightly different system and joined that in the 2011 one. And it was very challenging because it's actually in the middle of the desert, as you might know, and it was actually built by the people that were going to the festival. So really no professional, I think it was only one engineer, was quite scared probably of this process. But the building really held on, and of course there was a lot of knowledge behind and previously done, and tests in Finland done. Here you can see a picture of the night ambience of the festival, and some images of the interior. This was again a test, and of course Burning Man, it burns, so I'm going to show you this beautiful things. It shouldn't happen, I'm sorry for the good that is no specific fire consultant here, but this was actually quite nice to see that anything is forever, so it was good to get the test done and move forward. But the very curious thing is that actually when it finished burning, you can see this is already almost done after hours. It didn't really collapse. The whole structure really held it. And we needed to. How many? I cannot recall the minutes, but we needed to actually move the structure and put it down. So it did hold structurally. We didn't know that. We didn't make calculations at all. It was a surprise. But it proves that that this material has certain qualities that other materials don't have. And the last part of the parametric design approach is going beyond. Like we tried after all the tests and so on to even propose this parametric and parametric design in a bigger scale. So we proposed this school in Pieksämäki, north of Finland, where it was basically a concrete slab and then a freeform floor plan and then full shell on top of it. So it's covering all the spans basically from only the edges. We went quite far. We proposed this to the client. We won the competition actually, but at the end didn't manage to get it built. But we got actually a lot of input with the engineers, with the HVAC, with all the partners that we had in the competition and in the execution phase. So we got as far as like very specific details from the engineers, where we solved all the details. Like you can see here, for example, almost ready to get built, 4 meters beams which were connected in certain ways, and everything was pretty much studied. This will happen in the school. Actually, there is nowadays buildings all over the world that resemble this quite a bit. We tried in 2015 and didn't manage, but now it's really again becoming trendy, and because it offers different possibilities. This kind of dome architecture, it offers a free floor plan, and with the learning environments, it has a very big potential. So yeah, we know what is the present. We're all working on the industry, sustainability is a process. We know that things are changing and we need to adapt with it. But what is next for us, and what is the future of wood and architecture? So I'm going to show what we're working just right now. And first project is this Tonismägi State High School, which is a school in the center of Tallinn, very nearby the National Library. It's 8,000 square meters, and it's basically called a sustainable and resilient platform for learning. So it's connecting the two kind of themes that we have been working for many years. It's a very specific project I want to show, because even though it looks quite woody, we faced a very severe problem in the competition already, because at that time in Estonia the regulations were not catching up yet with the high rise in wooden construction. So we knew that was a bit risky to propose the wood. It happened in the past, so we knew that maybe let's propose something a bit more straightforward. So it is Tallinn is in the other side of Helsinki, in Estonia, capital of Estonia. So we proposed post-beam concrete building, trying to minimize the amount of concrete, but still we wanted to highlight the wooden use. Here you can see in the corner the Estonian National Library. The Embassy of Germany is also next to us, and the WoodWorking Institute. And the school is basically this L shape, which is terracing towards the wooden housing that is surrounding our building. So we wanted to create also a safe, natural space for students and neighbors to enjoy again the nature. Here you can see the strategy in a diagram. So we had terrace building, which also expands the learning environments towards the outside. And we had this kind of core of the building made of wood. And we proposed in the competition to be really wood. In the competition actually was a log type of construction that will kind of frame the wooden concrete structure. And we have just submitted everything now, and it's going to start construction potentially in a few months. And we changed it all to CLT and solid wood, which is to us a good success, because now we are testing in another country solutions that we have been doing for many years in Finland. So it's a step towards something new. Hopefully will look as great as the images, and a bit more about the learning environments. So also the idea of using the interior spaces and the exterior spaces as a continuum, so that you can not only stay in the classroom, but you also use the space of the outside. You connect to the nature, you connect the neighbors to the community. And also in this case, we thought it's very important the flexibility of the floor plan. So this is the up there, you can see the basic distribution of most of the floors, with a central corridor which is very wide. So it's called like open learning space, so everything can happen in there. But in the future it could be something else, because using a post and beam, and you can transform the building pretty much on anything you need. Here an image of the upper floors, where you have the yard on this side and the classrooms on the right side, and this open learning space for the high school. So that was a test. We were going to build it. We're happy with the process, but we kind of keep on pushing. And this is another project that we actually recently won, was at the end of 2022, which is Gladys School and Community Center in Tartu, which is the second biggest city of Estonia. It's also the capital of the education. It has the Minister of Education, so it has a very strong kind of presence of education in the city. It's also a university city actually. So we proposed in the competition, this time for sure, full wooden construction, but we took kind of a route that we knew that would be more feasible, which is to take at maximum 3 floors, because again, the sprinkler systems and regulations and so forth were kind of catching up with Finland and other places, and that was and they are really promoting also the wooden architecture. So we thought that was safer to do it in 3 floors at max and not going over it. So we proposed the whole community village in very low levels, starting from the daycare, the school, the 3 buildings in the middle, and the sports center in the left. And again, the nature and the landscaping was a crucial part of the whole proposal. So Tartu, it's going southeast of Estonia, and this was the original kind of commission plot, basically fields in the outskirts of Tartu. So we hooked to it quite strongly. We placed the buildings in the north where the big growth will be, and we left the rest of the space fully for nature and community and biodiversity and all the sustainable elements that we've been working with. The idea of the farming landscape was retained, so you can see in the side plan that we create these kind of lines with different activities for the community, and the idea of having the urban in the north road and the ecological going through the building, and then the building again opening back and forth from the inside to the outside and including nature inside the building. And the overall architecture idea was basically covering these roofs with the very big cantilevers, which is something that, as you saw before in one of some of the projects, that we are trying to get these cantilevers up so we can control the lighting, we can control the sun radiation, we can protect the wood actually from the harsh temperature. So this is the entrance image of the school, and you can see also staircases going up, and this was proposed in the competition to be fully wooden architecture, and it seems that it's going that direction. We are actually starting with the daycare, which was the building up in the right, which is 1 floor, and which will allow us to study all the technical and details and energy solutions that we have been pushing in the competition. This will be the canteen of the school. You can see mainly wood exposed. We know that has a lot of, we will face a lot of not fights, but conflicts and fire-related things and so forth, but we are now setting the base so that we're going to try to get this as far as possible with the competition ideas. And here an image from the other side where you can see this Boston beam system, sort of a system that feels that it can be expanded everywhere else, and it's very simple and very approachable, and also very nice feeling for the students to come to the building. From images from the interior, this is the school part, 2nd floor, where you can see also we created this science yard, we call it, so you can have also like a winter garden space. It's half heated, so it doesn't have that much cost to the building, but you still have this kind of connection to the nature. So in this image you can see that it will be winter outside, but you will have this kind of natural greeny feeling inside, and we'll try to get all the as close as possible to these images, because we really thought that this would be the school of the future for Tartu. And last but not least, this was released actually on Monday. We heard that we won this competition together with Kobe, Danish company, for the new Espoo house, which is the replacement of the city hall of Espoo. I think someone has talked already about Espoo. And we proposed a new meeting place for citizens and decision makers. So I'm going to go very briefly. It's around 24,000 square meters of the Espoo house, and then 25,000 square meters for the housing around 4 blocks. And it's in Espoo, which is the city attached to Helsinki, actually where the Aalto University is, and there's a lot of companies also based in there. Here you can see the map of Espoo and Helsinki in the side, and also the idea of, so you understand the competition brief. Espoo Keskus, the Espoo Center, has been always the administrative center, and it has actually, Espoo has 5 centers, so they wanted in the brief to make something in the middle of the city so that it's for everyone. It kind of connects all the different centers. So we proposed actually even in the bigger scale, in the master plan level, a ring in the natural areas, again using the sustainability and the heritage and the concept of greenery in the proposal. We had a bit similar situation with the train line as in the first project that I showed. The solution in this case was already proposed by the city, that we'll have a bridge that connects the city on 2 sides. But again, the idea of connecting the 2 sides for us was very important. We also created this ring, natural green ring that connects the historical buildings. There's the Cathedral of Espoo, there is a music building in this corner, the old station next to the train, and even the south part of Espoo Keskus, connecting all the historical elements and trying to make really like a new center for the whole Espoo Center community. And not only for Espoo Center, but the whole Espoo will actually come to the building. So the building itself was proposed like this, fully in wood. It's 8 floors, wooden architecture, and cladding in the wooden facade and wooden structure. And this is the view from pretty much the tracks when you get out, and a very open ground floor and also very open top floors, and that was actually the main concept of the proposal. That normally city halls have been very exclusive and the people meet there and decides. We proposed a building where actually it is very inclusive and it becomes an icon because the people actually can get in and get out and see the whole city. So that's again another image from the square. Here you can see the bridge that goes to the station and this kind of periscope elements that opens the views towards the different angles and different views, very beautiful views from up there. So the concept of green and sustainable goes around the building, the idea of having open for the citizens, the ground level but also the top level, and this kind of atrium which is the kind of the meeting space between the decision makers, the administration and the citizens. So here you see an image of the interior where you can see this lush green and trying to create this kind of biophilic architecture, using wood, using concrete in the ground level, creating this kind of landscaping situation to connect the different levels. And the idea of the periscopes, the idea of the access is being very natural and very open, very easy to use as a building, and the idea of having the top floor also accessible for the citizens. Here you can see some renderings from the ground floor levels, so that's the main entrance from the square. That's the situation in the offices, so pretty simple post and beam wooden architecture, and kind of the jewel of the building, which was the city council, which in the competition was proposed to be in the second level, but we decided together with our collaborators to really place it up there, because if not, it will have hiding somewhere else. It would have been again a bit of an explosive element. So since it was proposed to be a multi-purpose building, a multi-purpose city council, we proposed it in the roof with views to the nature, with wooden being, even interior-wise, being very strong. So you can see this will be a situation, for example, for a city, like a community meeting and so forth. And this will be a situation for the city council, and this will be a situation for some art even. So you can see the multifunctionality of the space and really trying to open the building to the citizens. That was the main idea. Here again, the periscope ideas, I think we'll go a bit fast because it's been too long, but the idea of
actually we need to finish.
Yes, it's fine.
It's been 30 minutes.
It's good. So that's pretty much our presentation.
Hello everyone, my name is Mikko and I'm from Puutuoteteollisuus Group, and Puutuoteteollisuus means wood builders, and we are only building with wood, in fact. Yeah. So 2006 established company, and at the moment we are the biggest CLT contractor in Finland and LVL. We do engineering, contracting, different kind of construction contract types. We can have only element providing or design or as a total, like a whole project. We have done in Finland over 200 square meters of housing with CLT and LVL. Mainly the first 10 years we did, because of the regulations, we did private housing, and since 2016 we have done only daycare centers, schools and apartment buildings and so on. A lot of event arenas and so on. If we compare to, this is our Hopelatu daycare center. If we compare to concrete house, concrete building compared to CLT, LVL building, it's about double the amount of emissions that are impacted in this this carbon storage compared to what it has the emissions when we build it from the concrete. So the effect is about double. We have we try to use as solid as possible. Whatever we don't use, for example, this is outside wall, and we are living in Finland. It's minus 30 degrees outside. We don't have any insulation, only solid wood, 240 millimeters, and then some kind of ventilation space. And this, in this case, we had larch. It's in fact, this is the last place that is in Finland. We are using Russian Siberian larch, which is really excellent wood, but now we can't get it, and that's quite obvious why we don't do that anymore. and large has excellent properties for building, because you can keep it without maintenance for 50 to 100 years. Of course, in some occasions we have to use some other materials with the CLT. For example, this Latnord daycare center, we had a wall structure because inside this outside goes tram in the future, and there's a kind of decibel issues. We have talked with acoustic issues a lot already, and with CLT and LVR as wood, the high hertz is they are quite easy to tackle with wood, but the low frequencies are the issue. Over or less than 100 hertz is really the issue. So because there's tram, we had to do this insulation outside, another material on the facade, and this is according to the Excel of acoustics, because of course you have two ways to make your point when you are getting the construction permit. You have to prove your acoustic issues via Excel, that this has this much decibels and this one works like this, or by measuring. And this case we did with Excel. So it said in the Excel that this wall would be about 13 to 12 decibels worse scenario than this one with insulation outside. Actually, when the building was finished and we measured, the difference was 2 decibels. That's one of those reasons we measure all our buildings, vibration and acoustics, because all the time, next building we do different than before. Wood building and wood construction is not ready, not up to 5 or 10 years from now. It's not going to be, no one can do it, because we are always searching for the efficient way for the next construction. This is a Finnish Russian school, or it's really Finnish, but there is a lot of Russian people living in Finland. Finnish Russian school we did in Helsinki, and it's 6,500 square meters, and this is about fire regulations. When we did Latnord daycare center in the same city, on the other side of Helsinki, they demanded sprinkler system. On the other side of Helsinki, they did not demand sprinkler system. We only used fire protection, the B class, inside of those buildings. So again, that's kind of those issues that according to the process and design phase, we don't quite know what we are building with what kind of techniques when we start the process. It's a bit difficult in Finland at the moment, especially when it comes to acoustic and fire regulations. As Tomi already told, it's a national thing, so they don't know it, what to do with it. Soft benefits for wood construction. There is a lot of studies, especially the Stora Enso has done great work with this one. There is a lot of, for example, the teachers has lower blood pressure in wooden schools than in concrete schools. And children are learning faster and better, for example, in wooden schools and in concrete schools, which is really strange, but they are pretty valid researches that has done. Air quality, of course, because of the moisturize that it breathes with you and at the time of the year. Of course, it requires few components, because when we are building a construction site, it's usually so that we have really high 3D modeling, because all of these elements are installed via our mobile application we have done together with Stora Enso, for example. So we don't use any paper. Our installers don't use any paper when they install those. We don't have any drawings, blueprints. We only use mobile phones, which is quite strange, but it really works. It's quite efficient. So, and all of these elements, of course, 3D modeling is really sharp, and this is really accurate, the CLT, as you know. So everything is kind of all the cuttings and everything is done in prefabricated. So installing is really fast together, and you have to be really accurate, because if you think and compare to, for example, concrete buildings, you can have a tolerance for 2 or 3 meters high. You can have even 3 centimeters, if I recall right. You can have the tolerance for concrete housing, and then you can have some kind of plaster or whatever, you can make it straight afterwards. But with CLT you can't do this, because all of those elements are in 1 millimeter kind of a sharp. So that means when we start from the groundings, that's it's plus minus 2 millimeters when we start building it up. So that comes a bit tricky, how to start really fast to build the wooden house, because you know that concrete it's not accurate ever. You can't make an accurate concrete foundation, for example. You have to have some kind of methods to start the building, so that you can have 3 or 4 or 8-story houses, what we have done, so that the line stays straight. If you get my what I'm saying. So it's first of all it's really fast to assemble. It is a 5-story high school we did. It's a 36 meters by 36 meters and 5 stories. And from the foundation up to the roof, it took less than 8 weeks. And all this facade and windows were closed, so the wall stays in 8 weeks' time. So when we are doing normal timetable for wooden construction, you can't use any old things or concrete processes. You have to think from the wood perspective. You have to think all those plumbings and everything else according to when we have installed ours. So everybody else has to adjust their timetable to us, not the other way around. For example, if we think in Finland, our revenue is about 30 million euros, so we are really tiny compared to those concrete buildings, concrete companies. They have billions of euros of revenue per year, and what is like 3% or 4% of multi-story houses in Finland are made out of wood, so it's really small. Finland it's really small wooden construction country, in fact. Because of the value chain, we also we founded this timber point which you are coming. This small factory of CNC machining in Loviisa, about 5,000 square meters. And the idea is that we have only Hundeker and open space, because we can't have a line for rig panels or have a line for modular elements, because in Finland the construction business goes like this, and we have to target all the time what we are doing today. We can't make that. We are doing only prefabricated models. If we would do that, we would be in bankrupt for 2 or 3 years. So because Finland is really a small business. So that's why we have the Hundeker photon machine there. We can, and what's the difference with the other ones? We can do 44 meter long wooden elements and the processing for that. That's the biggest in Northern Europe that you can make. Of course, we have structural gluing permits there. We can use Metsä Wood products and Stora Enso products. We can do our own brick panels or our own, for example, these intermediate ceiling types, which we have done because we optimize every time. We have to tackle the vibration in that, and we have to tackle the thickness of the wood, because we don't want to use too much of the wood, of course. I try to be fast because we are late, and I hate late. So let's go. Anyways, what we are doing, we kind of when you should call us, and if I think what we are good at is that when the architect is drawing the first 2 lines and not shown to anyone else, in that stage, because we have to give the dimensions and these spans of the house so it makes cost efficient. If they draw too far, we don't participate anymore, because that's too expensive building, and if we participate in too expensive building, wood construction does not go forward. So that's a bit it's called karhunpalvelus in Finnish. What's that in English? No one knows. It's bear service, the right translation. It's a service for that one, but it hits you in the other ones. Anyways, so that's why I think that that's why we are doing the structural engineering and the guiding of that. We don't want to do that, but we have to, because there is because we believe too much of ourselves that we can help with that one. We do element manufacturing. That's the high school I was talking about, by the way. Transportation, element assembly, and finishing interiors. We have a lot of carpenters working. I myself am also a carpenter. According to this this circulation, it's really easy to change or disassemble these houses and to transport to another place, for example, or do cutting for a new house, for example. The problem is that in Finland, at the moment, the law says that you can't use load-bearing structures twice. So it means that everybody is talking about in Finland that you have circular economy, you have to reuse your houses or something else, but the law says you can't. So it's a bit tricky, but it's really true. But it's designed mainly so that you can remove the screws and you can do the circle saw and cutting, and you can go to the factory and you can do the sanding and you can do the cutting, and you can make whatever you want to do with that one. For example, this one was a wooden pavilion from Metsäwood we did in Tokyo. We did all the prefabrication in Lovisa, put it into few containers, and we built it in 2 weeks in Tokyo. And it's totally movable. This whole, it's a few hundred square meters of pavilion. And it's an excellent example of recycling. We have a few case examples. That's a wrong picture. But anyways, it's a carbon handprint of wooden house. This is again Finnish law. We can't say carbon footprint and minus it from the life cycle emissions. In Finland, it's prohibited to say the same. So that's why we have to make a separation of how much the storage is per square meter and what is the cradle to grave in 50-year span of LCA, one-click LCA calculations. At the moment, we are doing also Maatuli School. That's 9,900 square meters approximately to Helsinki, and about 1,000 people comes in there, and it's a huge school building up in Helsinki. Stora Enso headquarters, we are building that one also. It's a 4-story office building. It stores over 6 tons of carbon inside. So I believe that has the most carbon storage in Helsinki region, or in fact in Finland, in one building. And for example, again, one detail in Finland, we can't have revenue of carbon storage because Finland state takes all these all the woods that grows in Finland, all the houses that are built in Finland, everything, the wood comes from the border inside of Finland. Finland capitalizes that the government in their own wooden own carbon balance sheet. So that's why it's not a business in Finland. If we go to abroad, we can use carbon storage and sell it out, but not here. We did this prefabricated models apartment building in Haga. This is the first EU taxonomy lending we get from Nordic Bank, for example, and it's really tricky. So first of all, it has to be A energy class, and it has 12 thermal energy, and it has a bit of wooden solar panels in the roof, so which means in European Union the EU taxonomy means that it's a green bond fund. It means that the European Union guarantees the loan with lower interest to Nordic. So when we get this loan for these apartment buildings and people buys the flat, they get really low interest rate for 60% of this apartment price. So it actually means about 50 euros per month per person when they are paying the debt up to the end. So it's really something, and it's coming already in a lot of these. Verkkosaari Daycare Center, We have done massive amounts of different load-bearing structure types. In this one, we have CLT glulam, columns and beams, and CLT slabs with and joint structure with CLT and concrete. Because of the design grid, or the architect's line that we like, that we have a huge area as possible without load-bearing walls, that they can have these flexible areas to design whatever. So this one has 10 meters by 10 meters, and it's really excellent value, in fact, with wood and concrete. And on the thickness is 280 millimeters only with intermediate floor. That's really thin. We have a lot of these. And you are going to join soon. We did that one in Lovisa. So that's the tallest building at the moment, but our design phase is in Oulu 16-story house, that's 65 meters approximately. Kelniemi bought this building next year, it's about 60 meters. And this is the world's tallest building with, what is that betotanko? Truss bars. Tension bars. World's tallest building with tension bars. You have to use something to make the wind effect and the stiffening. You said that you have to use concrete, for example, this entrance kind of thing. We have done the same calculations, of course, and in Keoninen we are using the concrete one, but in our own we are using this CLT joint structure to get that one. But this has only with wood and the tension bars. It's 50 meters, and you can see the drill. That is 1.5 meters, and it has magnets that it can follow. So all these outside walls has diagonal drillings inside of those walls, so you can't never ever see it. But it's attached to the foundation with the tension bars from the top. We have done a lot of cases. We don't go through these ones because I'm running late. In some future things we are going to do. Maybe in the future we are trying to do wind turbines, all those. This is not our project, but I think in the future we are participating in this competition to do in over 150 meter talls of the wind turbines. That's what else? Nothing else.